Hello guys and welcome back to my YouTube channel. So today I'm going to talk about quadratic function in my video for Addmaths. But today my main focus is on types of roots. I have two things that I'm going to do with you today. One is types of root, and I'm also going to cover about the maximum and minimum point. So I will cover these two things, types of root and maximum minimum point. So comparing with other videos, I think this might be a longer one as I'm explaining two things today. So first I'm going to focus on types of roots. So what is types of root? There are many roots, so we can categorize them into a certain type. So that's meant by types of root. So there are three types of root in Addmaths syllabus for SPM level. First, there are two roots. In quadratic, you only have two roots. Sometimes it can be one root. Sometimes it can be no root. But is that possible to have no roots? The answer is yes. But then if you key in your calculator, you will still get answer. Somehow you will still able to get answer. But you know what? That's not the real answer. We will call them imaginary roots. Because they are not a real roots, so we name them as imaginary roots. So somehow your calculator, if you key in a quadratic equation, you can get answer. But it cannot be a real root. How you know whether it's an imaginary root? When you press your calculator, you key in, you will see this sign r dash I mean not dash, it's like arrow. You will see this in your calculator. This r stands for root, this I stands for imaginary, which means it's a fake root. It's an imaginary root. It's just imagination. It's not a real or exact root that we are looking for. So this is what you will see. These are the three types of roots that you will see in this quadratic equation. So whenever you can calculate, there are possible of having two roots. There can be two roots, or sometimes if you key in calculator, you also get the same root repeating twice. Correct or not? Maybe the x1 is 4, x2 also 4. So it's the one it's considered as one root. And sometimes, but it's very rare, but they do have. There is no root. If you key in your calculator, you will get imaginary roots. You will see this thing in your calculator. If it's an imaginary root, they will mention the r arrow I. That means imaginary roots. Sometimes they also show like this in the calculator. I arrow r, something like this. They show like this. Oh, sorry. This one is my previous video. My bad. So let's get back to this quadratic function. And for this, we have a special name that we use also. And how does the two roots look like? So when you will get two roots, when you will get one root, and how we name them. Now let's see that. So first thing, how we know whether it's two roots? By the graph. So you know a quadratic curve has this type of graph, right? Sorry guys, it's not easy for phone call. Let's get back to this. Alright. So for two roots, the curve will look like this. Let's just say this is a quadratic graph, and this quadratic graph will intersect in your x-axis. Correct now? Let's just say this is your x-axis. And you know that when in a quadratic curve, there's the x-axis, the part of the intersection are considered two roots, right? This is how the graph, if there's a two roots, the real roots, if they intersect exactly at the x-axis, the x1 and the x2, we call this as two roots. The graph will look like this. Or it can be this one for the a positive, or also known as a more than 0. If you're quadratic, the equation your a is more than 0, this is how your curve look like. If it's a less than 0, which is negative, it's going to be upside down, right? And somehow they also still intersect at 2 points. This x1, x2. So these are the possible graph that you will able to see if there is two roots. And you know what? We don't call two roots. We usually call them two real roots. The word real is very important. Sometimes they also say two different real roots. They call this way also. Now let's see the graph for one root. How the graph going to look like? So I'm going to put it here for one root. So one root means there's only one, so they will only touch at one point. So this, can you see the graph? They only touch at one point at the x-axis. So this one, we call it one real root. The real is very important. They like to use the word real. The word real can differentiate between the fake and the exact root. Imaginary and real, there's two different things. So the word real is very important. Sometimes they also say two equal real root, which mean two equal, which mean the x1, the root 1 and the root 2 is the same. That means they are one root lah, correct or not? Like just now I say x1 is 4, x2 is 4 when you press in calculator, right? The two equal root, that's what it means. And this is how the graph look like if there's one root. So two root, one root. Now let's look at no roots. So if there's no root, how you'd see, it's so simple only. So you have the x-axis and the graph. If no root, okay, you can see here. When the graph intersect at 2 points at the x-axis, which is at here and here, here and here, you can say two real root. If the graph just intersect at 1 point, you can say one real root. If no root means it didn't intersect at the x-axis, isn't it? So how the graph look like? It will be a little bit higher or it can be lower than that. It depends on the equation. So that means you can see that it didn't touch at all the x-axis. There is no touching. So this is how the graph look like, and we call this type of root as no real root. Sometimes they also call imaginary roots, which I mentioned. What else? Mostly these two. And for each of the roots, we have an equation that can represent them. And the equation actually take from the quadratic formula. So the quadratic formula, I hope you guys still remember, but just in case if people forgot, I write it here. X equals to negative b plus minus b square minus 4ac over 2a. And the equation actually comes from here, which is actually this one, b square minus 4ac. To represent the type of roots for every graph that I mentioned here, we will use the b square minus 4ac. So the equation for two roots, we will use b square minus 4ac more than 0. If it's two root, they mentioned two root in the question. Just remember this equation, b square minus 4ac more than 0. If just one root, then your equation going to be like b square minus 4ac but equals to 0. And if there is no root, it's going to be less than 0. So these are the equations that you have to remember for each type of graph and each type of roots. This, and this. Alright, clear? So all you need to know for type of roots and the equation and the graph is this, and how we call each type of root. So for two roots, we sometimes call two real roots or two different real roots or just two different roots. And you need to know how the graph look like and the equation that represent that, which is b square minus 4ac more than 0. If one root is equals to 0, if there is no root, is less than 0. It's just like that. Only thing changes is the sign. If 2 is more, if 1 is equal, if it's no real root, then it's less than 0. The sign, the inequalities. Only that is the difference. And the rest are the same. So for example, I give you an equation. So let's just say example 1. I give you an equation x squared minus 6x plus 1 and equals to k. And I say this, find the value of k if the quadratic equation given have two real and equal roots. So how are you going to find? This is the common type of question that you will see for types of roots. So x squared minus 6x plus 1 equals to k, and find the value of k if the quadratic equation have two real and equal roots. So they will mention the keyword that I write here. So from there you need to analyze which category or which type the roots come from. So I clearly mentioned here that it comes from two real and equal roots. The important word that you really need to highlight is the word equal. Two equal roots. That means the equation that you have to use is b squared minus 4ac equals to 0. No matter what, this is the equation that you're going to use. So you need to sub inside the value of b, a, and c. And you have your quadratic equation. X squared minus 6x plus 1 equals to k. So what is your a, what is your b, and what is your c? And if you realize, this quadratic equation is not a standard equation, because a standard equation will look like this. Just in case if you forgot, I'm writing here ax squared plus bx plus c equals to 0. This is a standard quadratic equation form. But in this case, you realize that this is not equals to 0, but is equals to k. That means this is not a standard quadratic form. It's not a general form. So what is your first step? First thing, you have to bring all this quadratic equation into a general form. So let's bring the k to the other side and make it equals to 0 so that it looks into a general form. So x squared minus 6x plus 1, and the k you bring to this side, it become minus k, and this will be equals to 0. So you can see the pattern now. Ax squared plus bx plus c, and this will be equals to 0. So your a is this, but there's nothing, so we assume it's 1. And your b is negative 6, and your c is 1 minus k. Let me highlight 1, negative 6, 1 minus k. You just can't take 1. There's negative k there, so you need to take that. So a is equals to 1, b is negative 6, and my c is 1 minus k. So I got all of my unknowns ready, so what I have to do is sub inside the equation b square minus 4ac equals to 0. So let's substitute. So my b is negative 6 square minus 4, and my a is 1, and my c is 1 minus k, and this is equals to 0. So negative 6 square is 36. So 4 times 1 is 4. So negative 4 times 1 is negative 4. Negative 4 times negative k is positive 4k. And this is equals to 0. 36 minus 4 is 32. So 32 plus 4k equals to 0. And my 4k, the 32 bring to the other side, become negative 32. And then you can just divide it by 4. So you will get 8, negative 8. Tada! I find the value of k. So they will actually, don't worry, they will tell you the keyword. And you just need to generate the equation. There's only 3 possible equations. B square minus 4ac more than 0, b square minus 4ac equals to 0, b square minus 4ac less than 0. And each they will mention the keywords specifically and clearly. You don't have to worry. For more than 0, that means 2 real root or 2 different roots. Equals to 0 means there's 1 real root or 2 real and equal root. The word equal or 1 root. And if it's less than 0, it's either imaginary roots or no real roots. So I give you another example. Maybe example 2, and I'll give you a equation x square minus 5x plus 3. This is equals to k. And the same thing, find the value of k. If the quadratic equation have no real roots. So if the quadratic equation have no real roots, the keyword is no real roots, or they do also say imaginary roots. This means one thing that comes in your mind, b square minus 4ac less than 0. You have to remember the equation. They don't give you in the formula sheets. So it's a must remember. They only give you the quadratic formula. And now you need to find out your a, b, and c. So they give us the quadratic equation, right? So x squared minus 5x plus 3 equals to k. But you realize this is not in the general form or the standard form, so you have to bring it until you get the standard form. So you have to make it equals to 0. So the k you have to bring to the other side. So when the k you bring here, it will be 0. So x squared minus 5x, the plus 3 remain, and the k you bring to the other side. Positive bring here become negative k, and this will be equals to 0. And actually you can see the pattern, ax squared plus bx plus c equals to 0. And there you go, this is my a. My a is 1, my b is negative 6, and my c is 3 minus k. Give me a moment. I shouldn't say find the value, I should say find the range. Of my bad. For this type of question, you can't find the value, but you can find the range, because the equation will be in the inequalities form. So you can't find the exact value, but you can find the agak-agak value, the range, because it's in the inequalities. So now let's do this. A is 1, my b is negative 5, C is 3 minus K. So you got your A, B, and C, right? Substitute inside the formula. So my B is negative 5, so negative 5 squared minus 4. My A is 1, my C is negative 3 minus K. This will be less than 0. Substitute inside the formula is very important. So negative 5 squared is 25. And negative 4 times 1 is negative 4. Times 3 is negative 12. And negative 4 times negative K is positive 4K. This will be less than 0. 25 minus 12 will be 13. 13 plus 4K will be less than 0. And the 13 you can bring to the other side. So when you bring to the other side, the positive 13 will become negative 13. And my K, so the 4 bring to the other side, negative 13 divided by 4. Done. This will be the range of my K. I didn't find the value, yeah, I find the range. Because you can't find the value. So I give you another example for equal roots and no real roots. And I think I should give you example for two different roots. Yeah, two different roots. I need to give example for that. So that will be my example 3. So these are the possible type of questions they will ask in exam. Okay, I give you 3x squared plus 2x plus k and equals to 5. A bit different. And I say find the range of values of k for the quadratic equation that have two real and different roots. That have two real and different roots. So how are you going to find? First thing, highlight the keyword. They say two real and different roots. If this thing they mentioned, the first thing that you need to write in your exam paper is b squared minus 4ac more than 0. It should be more than 0. The sign, the arrow, it is more or less or equal. This is the important part. And now they give you a quadratic equation. So they don't give you in a standard form or general form. You have to make it into a general form. So 3x squared plus 2x plus k, and this is equals to 5. So first thing, bring into general form. So when you bring into general form, you have to make it equals to 0. So the 5 bring to the other side become negative 5, right? So let's do that. 3x squared plus 2x plus k minus 5 equals to 0. And you can see it's in a general form already, as this is your a x squared plus b x plus my c equals to 0. So this is my c, k minus 5. My b is 2, my a is 3. So just sub inside the formula. My a is 3, my b is 2, my c is k minus 5. So b is 2, 2 square minus 4, 4. A is 3, c, k minus 5. Sub inside. And more than 0. Now you just do your normal math. 2 square is 4. 4 times 3 is 12. So minus 12k. And then 12 times negative 5 is 60. But don't forget to put positive. And 60 plus 4 is 64. So negative 12k plus 64 more than 0. And the 64 can bring to the other side. When you bring to the other side, it becomes negative. And the negative can cut. Remember I told you, right? If you're negative, you cut, what happened? Sign terbalik. So reverse the sign. So that's my case, 64 divided by 12. If you press in your calculator, you will get 16/3. Done. There you go. So this is types of root. Nothing much. They don't really ask a lot because it's only these three things only. These three type of equation and the graph and the name, the categories, that's important. We are done with type of roots actually. So just a quick recap you need to know. Maybe I'll write them again. So types of root got three types. It's like a summary I'm doing again. One is two roots. Another one more is only one root. Another one more no roots or zero roots. Not to say zero root, they will have roots, but they are called imaginary. So maybe no real roots. So these are three types of roots. And for two real roots, the quadratic equation will look like this: b square minus 4ac more than 0. For one root, it's just 1, right? So it's equals to 0. And for no real root, it's less than 0. And the graph, because you need to know how the graph looks like. So let's just say this is my x-axis. If two roots, it will definitely touch at 2 points. Why it's not sitting in a perfect shape? So there are two roots that intersecting. That's why it's called two real roots. One root means it's just touching at 1 point. It intersects at x-axis at 1 point only. Something like this. Oh, it forms a circle. So you can see it touching 1 point. And no real roots, that means it didn't touch at all. It either at the top or at the bottom, but it did not intersect the x-axis. Something like this. So this one intersect x-axis at 2 points. This one intersect or cut the x-axis at 1 point. This one, no cutting at x-axis. So this one, sometimes the keywords they usually like to mention is two real roots. Two real or different roots. This one, two equal roots or one real root. This one, imaginary root or no real root. So this is the thing that you have to know for types of roots. There are two roots, one root, and no real roots. And the graph, the equation. Mainly it's equation because you will use equation to answer the questions. It's math. So the equation is very important. Now, actually I'm done with types of roots. So I'm going to cover about the maximum and minimum point. So this maximum and minimum point requires a bit knowledge in your completing the square. You need to have a idea on that part. Completing the square, it's a must. So let's talk about the maximum and minimum point. So first thing, Let's go for the basics of quadratic function first. So if let's just say I have a curve like this, you have to know this is a smiley face, so your a will be positive, or we also say as a more than 0. If your a is more than 0, smiley face, that means this point at the very bottom will be the minimum point, because it's at the bottom there. It will be the minimum point. And the minimum point not referring to the x-axis. Let's just say I have a y-axis, maybe somewhere like this, fx. So this thing, the y-axis referring the minimum point. And what about the x-axis? The x-axis, this x value the quadratic will represent the axis of symmetry. Represents the axis of symmetry. What is axis of symmetry? Which means at the middle part, the middle of the graph, the quadratic curve, the middle part, that the middle part you cut, the x value is the axis of symmetry, and the y-axis represent the minimum point. So the coordinate of this will tell you two things. One, you get to know the axis of symmetry. One more, you know the minimum point. If your a is negative or a is less than 0, how does your graph look like? So it will look something like this. Since it's negative, it will have a sad face. Maybe something like this, x, fx. So the possible of graph for quadratic, only these two graphs lah. One is a positive, one is a negative. A cannot be 0. If a is equals to 0, then there's no quadratic curve. It either be a straight line. So what will be the stationary point? It will be the maximum point, the top, this maximum part at the paling very atas one. The top part of the quadratic curve is called the maximum point. This one referring the maximum point. The y value telling you the maximum value, and this thing, the x value, same. It will represent the axis of symmetry. So there will be a difference in terms of naming, which is the minimum or maximum point. If your a is negative, we don't say minimum point, but we say maximum point. If your a is positive, you have a smiley face. So when you have a smiley face, you will have a minimum point. If you have a sad face because you're negative, your a is full of negative, so you will have a maximum point. Generally, these 2 points, we call them stationary point. Or the turning point. But you don't have to know the name of that, because you'll learn that further in chapter 2 from 5, differentiation. So you will learn later on. Don't have to worry for now. Generally we call stationary point or turning point. But for now, you just need to know there's 2 types of point for quadratic function. Either it's minimum point or maximum point. How we identify? Looking at the a value. If your a is negative, you have a sad face, so the curve will look something like this. So the peak, the paling atas will be the maximum. If you're a negative person, then it will be sad face. If you're a positive person, you're full of smiley happiness, so you smile, so it will be the minimum point. So you just need to refer the A value. The A is very important. How you know whether it's your A is negative or positive? I hope you should be know. You just have to refer the quadratic function, the general form, ax squared plus bx plus c. From this, if your A telling the A from here, if you see a negative, your graph will look like this. Positive, your graph will look like this. And now, that's not the matter. The important thing, how are you going to find the minimum and the maximum point? That's the important part. That's what I'm going to cover. Because the thing is minimum and maximum point. That's what our main study is. But the thing, how are you going to find? So you know where the minimum point and the maximum point were located at the quadratic curve, where they will see, where you can see. From the graph you're able to visualize, but how are you going to get it from the calculation? We can get it through a method that we have already learned, which is called the completing the square. So if you do completing the square, which is the short form of it is CTS, you will be able to find the minimum and the maximum point. But I told you before, the completing the square only can use to find the roots, which is the x value. But now I'm also saying to find the minimum or maximum point. How is that possible? Here is a way. You don't have to exactly do the same thing. Like you have to find the maximum or minimum point. I mean, you don't have to find the roots for completing the square. Yeah, you know, that's the main purpose that you do in the previous video. But in this video, the thing, you're not going to find the x value, but you're going to look at the minimum or the maximum value. I will show you how one by one, so don't worry, don't get worried, because completing the square has many functions. There are a lot of things that you can do from the completing the square. Besides finding a root, you can find the minimum or maximum point. So for example, I have a quadratic equation. Maybe fx my fx, I couldn't think of anything, equals to 2x squared plus 5x minus 6. Let's just say this is my quadratic function. How I'm going to find the minimum or maximum point? You have to do completing the square. And remember the condition I told you, how you're going to use the completing the square? There are two things that you have to follow. First thing, your A must be equals to 1. Second thing, the formula, sub inside the formula x plus b over 2 square minus b over 2 square plus c. Remember I told you this is the formula? You have to do these two things, right? Exactly the same thing. First thing, your A should be equals to 1. But in this case, you can see 2x squared, your A it's not equals to 1, but it's equals to. So the first thing you have to do is make it into 1. How? Divide. So if you divide 2 divided by 2, you will get 1. So are you going to divide to everything? Okay, 2 divided by 2, you get x squared. 5 divided by 2, you get 5 over 2x. Minus 6 divided by 2, you get minus 3. But how are you going to divide to the fx? How? You can't divide 2. Function cannot be divided by 2. So what you'll do for this one, you won't divide by 2. But instead of dividing 2, you will factorize the 2. That means you take away the 2, put it outside. That's what you will do. You don't divide by 2, but you take the 2, you put it outside. So 2, you put it outside. So when the 2 you put it outside, the x square remain x square. And then the 5, you divide by 2, right? Then you pull the 2 outside, right? So you do the same thing. And then the 6, you take away the 2, left is 3, right? So minus 6 over 2. Minus 6 divided by 2 is 3. So you can actually double check. If you times, you expand the bracket, you will realize you get back the same thing. So you see, I didn't divide by 2, but I just factorized the 2 out. I didn't remove the 2 like terus. I didn't eliminate the 2 from the equation. I maintained the 2, I just put it over there. I didn't change anything. I just factorized and put it out. Because in this case, you can't divide by 2. It's not equals to 0. Because it's equals to 0 means if your ax squared plus bx plus c equals to 0, and then yes, it's possible for me to divide by 2 because it's just 0. 0 can divide by 2, you still get 0. But this time, it's not equals to 0. Function. Quadratic function means you got fx. Fx cannot be divided. So you just have to factorize. It's not equals to 0. It's not a number to divide. It's a function. So you have to factorize. You have no choice. You have to bring the 2 in every single step. Next thing, after I factorize, somehow I still able to make my a equals to 1. You can see here. You realize my a is not 2 anymore, but it's just 1. And my b is 5 over 2, my c is negative 3. And I can actually sub inside my equation, which is this one. Just bring everything into the equation. What's your b? 5 over 2, and your c is minus 3. So put inside that x, put x. B is 5 over 2 divided by 2. Then minus b is 5 over 2 again. Square and plus the c. My c is negative 3, right? So minus 3. And don't forget, bring the 2, maintain the 2, because you can't do anything the 2, right? So just put at the 2, just like at the side there, like a bodyguard. And now the thing is actually the same thing. This part you have to press in your calculator, right? Yes, do that. 5 over 2 divided by 2 is 5 over 4. So minus 5 over 4 square. And now 5 over square is 25 over 16. Oh shit, my bad. I forgot to put the bracket. And you can press this entire thing in your calculator. Sorry guys, my internet was lagging just now. Okay, continue. So minus 25, negative 25 over 16. You just need to press your calculator. Minus the 3, you get negative 73 over 16. And don't forget, there is 2 here. So maintain the 2. And now what you have to do? Since the 2 is outside, so what you can do is just expand. So you times the 2 inside. So here times 2 here. So 2 times the bracket entire thing, you will just don't have to expand one by one. So just put closer. And negative 73 over 16, if you times 2, you get negative 73 over 8. And actually we're able to find the minimum and maximum point at this point already. At this moment, you actually can see the maximum and minimum point. How? Very simple. These two numbers will tell you the axis of symmetry or the minimum maximum point. So you know your A is 2, right? Your A is positive. You have a smiley face. You should have a smiley face because you are positive. So if it's positive, then it should be a minimum point. But what is the value of the minimum point, which I told you just now from the graph? The x and y, the axis of symmetry, and the y-axis, which is the minimum or the maximum value. I told you from the completing the square, and this is the completing the square. And where do I see that? These two, 5 over 4 and the negative 73 over 8. These 5 over 4 will represent the axis of symmetry, which is the x-axis symmetry, the x value, and the negative 73 over 8 will represent the minimum or the maximum value. Look at your A. For that, either is minimum or maximum is depending on the A. If your A is negative, and then it should be a maximum. If your A is positive, it's minimum. But axis of symmetry, be careful. One more thing, you have to reverse the sign. In this case, it's 5 over 4, right? But then if you're in the axis of symmetry, you have to reverse the sign. Make it negative. You have to reverse the sign. The sign, please change. That's the one thing you have to make sure remember. So I can say my axis of symmetry is negative 5 over 4, and my minimum value, for minimum value, you don't have to change the sign. It's negative 73 over 8. I write it here. Change the sign. So yeah, you can remember the positive and negative sign. If it's plus, then it's minus. You put minus. If it's minus, put plus. So plus there, put minus. That's your axis of symmetry. If they ask you the minimum point, and then the coordinate, minimum point. Point means coordinate. There's a difference between a value and a point. Point means you have to give in the coordinate form, which is the x and y. So what is your x? Negative 5 over 4. So write negative 5 over 4. And my y is negative 73 over 8. So negative 73 over 8. So your graph something will look like this. I just agak-agak. So your A is positive. This is negative 6. Oh, cannot be. Should be here. So negative 6, which is the y-intercept. How I know the y-intercept is negative 6? This thing. Maybe you can't see the y-intercept from the standard general form. And the minimum point. So this part is actually negative 73 over 8. And the axis of symmetry, which is the middle part cutting the x-axis between the curve, is negative 5 over 4. So the coordinate here will be -5/4 and -73/8. So this is how you identify the minimum and maximum point through the completing the square. And not only that, we have a name to represent the minimum and maximum point. We have a name. We call them vertex form. This is general form, right? If you do completing the square, you will get vertex form. And you know what? This thing is your vertex form. That's your vertex form. Your vertex form is a form that you actually will see your A, which is at the front there. The A value, this A, and you will see the axis of symmetry, the X, and you will see the Y, which is the minimum or the maximum value. So that's the vertex form look like. So in a general form, you will look the A, B, C. This is what you will see from the general form. In your vertex form, you don't see your B and C, but instead you will see your A, you will see your axis of symmetry, and also your minimum or the maximum point, depending on the A values, either negative or positive. So get it? I hope this helps you understand how to find. But don't worry guys, we will do another example for this minimum and maximum point. So maybe I have another quadratic function. I use another quadratic function, maybe fx equals to -5x squared minus 6x plus 2. So how I'm going to find either it's a minimum or maximum point? Look at the A value. Your A is -5. So your A is negative. You have a sad face. It's full of negativity. So because of that, you have a sad face. So if a sad face, you look, it's at the top there. Top is always a maximum. Why the screen is running? Should lock it. So because it's at the top, we call them a maximum point. Not minimum, it's maximum. So let's do this maximum point. And yeah, we need to find the value lah, the axis of symmetry, which is the cutting point, and the y value. How are you going to find? Completing the square. And remember, in this case, for quadratic function, you actually can't divide. All you can do is take and put it outside. So my fx -5x squared minus 6x plus 2. You can't divide the -5. It's not an equation, it's a function. So you can't divide a function. So all you can do is factorize it out. So you take the -5, put it outside. When you put it outside, you just left with x squared. And the -6, you take the -5. So remaining is 6/5. And the 2, from the 2, you pull out the -5, you will get -2/5. And you can actually double check though. You can actually times, and then you can actually see you will get back the same thing. 5 times x squared, -5x squared. -5 times 6/5. Sorry, here got x. 6/5x is -6. And -5 times with -2/5 is +2. Right? So you can see you didn't change anything. You just factorize and you write in another way. So, and you can see my general form. Ax squared plus bx plus c. This is my general form, right? Yeah. So what you have to do? You're already done with your first condition, which is first thing, make your a equals to 1. And your second thing, x plus b/2 square minus b over 2 square plus the c. So let's do that. Negative 5. The square bracket maintain, and your x sub inside 6 over 5 divide by 2 square minus again the b over 2 6 over 5 over 2 square and minus 2 over 5, and you actually can 6 over 5 divided by 2 6 over 10, right? And 6 over 10, if you simplify, should be 3 over 5. And you have to maintain, bring the negative 5, don't do anything for the negative 5. And actually this thing, press your calculator. So 3 square, 3 over 5 squares 9 over 25. So negative, you just need to press your calculator. Negative 9 over 25 minus 2 over 5, you should get negative 19 over 25. So this entire thing, if you solve, you should get negative 19 over 25. You just need to press your calculator. And x plus 3 over 5 square, maintain, don't do anything. And yeah, don't forget the bracket. And obviously the negative 5. And last, you just need to times in the negative 5 back. Times here, times here. So for this one, you don't have to expand back. You just need to put it aside. So negative 19 over 25 times with the negative 5 back, you get positive 19 over 5. So yeah, you are done, and you're able to find the axis of symmetry as well as the maximum point. So what is the axis of symmetry? Is this right? But don't forget, I told you, right, change the sign. It's plus. That means put a negative. Negative 3 over 5. Must change the sign. And the maximum value 19 over 5. This one you just copy paste. If negative, negative, positive, positive, you don't have to change the sign. And what if they ask the maximum point? People always get confused with this. If they ask you maximum point is always a coordinate. So you have to give the coordinate, which is negative 3 over 5 and 19 over 5. If they ask points, some people go give value. They will mark you wrong, although you're right. Your final answer, you won't get marked. There's a difference between the value and the point. So your graph, something will look like this. This is a negative. You should have a set face. Something like this, right? So this is your fx. And your y-intercept too. How? Look here. They already mentioned here. It's clear. Your y-intercept 2. And then the maximum point. So what's the value? Negative 3 over 5. 19 over 5. So that will be the maximum point. So the coordinate will be the negative 3 over 5 and 19 over 5. This will be the maximum value. If they ask you to sketch the graph, this is how you sketch the graph also. And yeah, don't forget the origin. Origin is also important. So once again, to find your minimum and maximum point, you have to do completing the square. And no matter what, from the general form, once you do the completing the square, you will get the vertex form. This is vertex form. And from vertex form, you're able to know your A, you're able to know your axis of symmetry, as well you know the Y, the maximum or the minimum value. So these two things you're able to get from the vertex form. If they ask you to find the vertex form, also do the completing the square. If they ask you to find the minimum or the maximum value, or they ask you to find the axis of symmetry, also do the vertex form. So yeah, that's it for today. I'm done with the types of root, the minimum and maximum value. So yeah, that's it. See you in my next video. And if you like my way of teaching, don't forget to like, share, and subscribe. Thank you. Bye. See you in my next video.